Hello, this is Dr. Oz. In this video, I would like to talk about probability uncertainty before I get started with my simulation and risk analysis chapter. Okay, so uncertainty is something that we need to be aware of because that creates risk. And I define risk as probability of a undesired outcome to occur. All right, so it's a numerical measure and it shows the likelihood of an event, unwanted event to happen if it's a risk. And we communicate the uncertainty through probability distribution. It's very helpful because then we can understand all the possible situations in our model. So let's talk about events and probabilities. So a random experiment is a process that generates well-defined outcomes. And for example, coin toss and rolling a die, these are random events that no one can consistently know the outcome. So let's talk about a couple random experiments here. One, tossing a coin, the outcome is either head or tail. Rolling a die, another random experiment, and the outcomes are 1, 2, 3, 4, 5, and 6. And holding a particular share of stock for 1 year, price can go up, down, or not change. Customers may purchase the product or not. Demand may go up, down, or doesn't change. Okay, so let's take a look at an example here, the completion times for 40 projects. And this is called empirical data or empirical distribution that we create. Basically, we look at the historical data for 40 projects in this case. 6 of them ended up being completed in 8 months, 10 of them 9 months, 12 of them took 10 months, 6 of them took 11 months, and 6 of them took 12 months. So now we can calculate the probabilities. Basically, what's the probability of the project will be completed in 8 months? Number of times it happened, which is 6, divided by total number of trials, in this case 40. So it's going to give you 15%. And to be able to call something as a probability distribution, all the probabilities needs to add up to 1. So what I would like to talk about now is some basic relationships of probability, such as complement of an event or addition law. So take a look at this diagram. You can see that there is an event A called event A, and complement of event A and event A together will create my sample space. For example, if I defined event A as Apple stock to go up, basically a complement would be Apple stock to go either stay flat or go down. When you add them up, it will add up to 1. That's why probability of A plus probability of a complement will be 1. All right, so let's take a look at another example here, which is union of event. What's the probability of an event A or event B occurs? So the keyword here is or. So we call this as A union B. Basically, this is gonna be probability of only A happened plus probability of A and B happened together plus probability of only B happen. So what could be an example? What's the probability of a student gets an A, probability of student gets an A in business analytics class, and also union probability, or I would say marketing class is A. So either or is gonna give you union. Okay, So let's take a look at intersection. This is basically and, that's the key word here. What's the probability of A and B happens? What's the probability that a student gets an A in business analytics and B and A in marketing? So that probability is obviously lower than or. So let's take a look at mutually exclusive events. Basically, mutually exclusive meaning that if event A happens, event B doesn't happen. If event B happens, event A doesn't happen. So you can see that they are mutually exclusive. So that's it for this video. Next video, I will talk about conditional probability. Until next video, enjoy business analytics.